Welcome back, Math140 students. This is your instructor, Cindy Enrique, and we're going to pick up on section 11.5, the irrational number e and change of base. So we have our logs, and we also now have a new introduction to e. So e is very similar to pi. Hopefully you remember pi. Most of you remember pi as a 3.14. But really, there's more to pi than just 3.14. If you plug it into your calculator, it's 3.14159264. And the truth is with pi is that it's never ending, never repeating. And for these types of numbers that are never ending and never repeating, we call them irrational. And another number that's very similar to pi is e. So e is just a number. It's about 2.71, okay? So we have this e, and it's really just kind of our base e that we're going to use in our logarithms. And we're also going to use e in some of our equations. So just know that that pi or that e is never ending, never repeating, and it's irrational. So for natural logarithms, ln, that's the natural log, ln, okay? And we know that whenever we see ln and e together, they cancel out. So notice how it says ln e. So whenever I have ln, and on the inside I have e, what happens is they cancel out. And then so I'm just left with an x. Again, I have e and natural log, and since they're inverses of each other, it cancels out. So just know that whenever I have ln and e, they are inverses. So they cancel each other out. So that's going to come in handy when we have to figure out how to solve these equations. So what we want to do is just get comfortable with e on your calculator. So let me go ahead and get that up for you. So it looks like our first one is going to be e to the 4.8. So e to the 4.8 value. So our e button, see where the 4 is? Then over to the left, it says ln, and then up on top that blue says ex. So I'm going to go with the blue for second. I'm going to press ln, okay? Then I'm going to plug in 4.8. So I know this is just going to be a number. So I have 121.5104175. So I'm going to go ahead and write that down, or actually, what does it say here? It's approximate to the 4 decimal values. So if I'm rounding to the 4 decimal places, 1, 2, 3, 4, that 4 is the 4th decimal place. So the 5th digit is 1, so that 1 tells you to leave that 4 alone. So my final answer, I'm going to have 121.5104 as my answer. Now I'm going to do the exact same thing, except now I'm going to plug it in with a negative 2.6. So I'm going to go second e and a negative 2, oops, notice how I didn't write in that negative, negative 2. Okay, so I have my e to the negative 2.6. Now I'm going to get my value as a decimal, 0.07427357882. Again, I'm still rounding to the 4 decimal places, so 1, 2, 3, 4. So the 4th digit here is 2. So the 5th digit is 7. So that tells me to bump that 2 up to a 3. So I'm going to go ahead and write that out. So I have a 0.0743. I'm just going to rewrite that 0 and that 7 a little bit nicer. I didn't like the way how messy it looked. So 0.07. There, that looks a little better. So 0.0743. Okay. Now for number 3, that one's slightly different. Now I have ln of x is equal to a number. So I'm like, okay, well, how do I get the value for x? Well, I already know from up above that says that ln, the natural log, and e are inverses of each other, so they cancel each other out. So what I'm going to do is I'm going to raise both sides to an e power. So now I have e to the ln of x is equal to e to the negative 0.0674. But what ends up happening with the ln and the e, they cancel each other out. So we're left with x is equal to e to the negative 0.0674. So I'm going to go ahead and plug that into my calculator so that I have e to the negative 0.0674. Now I'm going to get this number, and I'm going to go ahead and round it. So I'm going to get 0.9348. Okay. That's what I'm going to get what x is equal to. I just plugged that into my calculator. Now for number 4, I'm going to do the exact same thing. So I'm going to e both sides. So now it looks like e to the ln of x is equal to e to the 5.2. And again, I have my e and the ln that cancel. So you're left with x is equal to e to the 5.2. So now I just get to plug that into my calculator. So e to the 5.2 power, and I'm going to round it to the 4 decimal places. So 181.2722 is going to be my final answer. Okay. Now for example number 2, it tells me to evaluate to 4 decimal places, and I'm using my change of base formula. So my change of base formula tells me to rewrite it as such. So what this is telling me is that the b for base goes on the bottom and the x goes on top. So notice how on your calculator it just has log there. It defaults to log base 10 if nothing is there. So for example, so I'm going to rewrite this using my change of base formula. So I'm going to have log base 10, log base 10. So since I have my 5 as my base, I know that goes on the bottom, so that's going to be 5. So that 79 goes on top. So I'm going to plug this into my calculator. So on my calculator, I'm going to go ahead and plug in my fraction. So I'm going to have log of 79. And on the bottom, I'm going to have log of 5. I don't need log base 10. Your calculator by default is already base 10. So I can just plug it in as just log, okay? So I have log of 79 divided by log of 5. And this is what I'm going to get when I do log of 79 divided by log of 5. I get that 2.714890595. And again, it says to round to the 4 decimal places. So if I round to the 4 decimal places, 1, 2, 3, 4, 8 is 4 decimal places. So that 9 tells me to round that 8 up. So I'm going to have 2.7149. Okay. So I'm going to do that again and again. Okay. So I know I'm going to have my fraction, log, and log base 10 because that's what my calculator knows. And again, my base goes on the bottom, so that's going to be 6. So that tells me that the 806 is going to go up on top. So now I'm going to have my calculator, and I'm going to have my fraction. So I'm going to have log of 806. And down at the bottom, my log of 6. And when you press enter, you're going to get that 3.7349230.5. So I'm going to round to 4 decimal places. 1, 2, 3, 4. The 4th decimal place is 9, so that 2 tells me to leave that 9 alone. So I'm going to rewrite this as 3.7349. I'm just going to rewrite that. I don't like the way it looked. So 3.7349. Okay, so that looks a little better. And for part 3, we're doing the exact same thing. We're still using our change of base formula. So, okay, so I have my log and my log. Now I know that my base goes on the bottom. B for base, B for bottom. Okay, so I'm going to have 3 down my denominator. And up on top, I'm going to have my 0.0365. Now I'm going to plug that into my calculator. So, okay. I'm going to have my log of, oops, and that's natural log. I meant to say log, there we go. 0.0365 divided by my log of 3. And I'm rounding to the 4 decimal places. So 1, 2, 3, 4. That 4th digit is 2. The 5th digit is 9. So that tells me to round that up to a 3. So my answer I'm going to have as a negative 3.0133. I'm not really liking my zeros today. That's okay. That's better. So negative 3.0133 is going to be my final answer. Okay, so now we have more examples. We have ln, which is your natural log. So with the natural log, what comes here is going to be your one-to-one property. So what you want to do is condense it to a single ln on one side. So here, since you have addition, since it is addition, then combine for multiplication. That is our product property. So we're going to have this as ln, and of course it's equal to my ln of 5. So I have x, and I also have my x plus 4. So I'm just going to rewrite this. I have my ln equal to my ln of 5. So on this inside, I'm going to go ahead and just distribute that x. So x times x is x squared, and x times 4 is my 4x. So now that I have natural log on both sides, natural log on one side, natural log on the other, what you can think of is you're going to e both sides so that it can cancel out. So you're just left what's on the inside. So x squared plus 4x is equal to 5. So don't forget, whenever you have a degree 2, you always want to set to 0. So if your exponent is 2, then set equation equal to 0. So I'm going to subtract 5 to both sides. That way I can get x squared plus 4x minus 5 is equal to 0. And you can go ahead and factor this. So I have x times x is x squared. The only way to get 5 is 5 times 1. The middle term is positive, so a positive 5 and a negative 1. And that goes and factors correctly. So I factored. And now I set each one equal to 0. So x plus 5 is equal to 0. so x is equal to negative 5. X minus 1 is equal to 0, so x is equal to a positive 1. And remember, before you box your answers, you're going to check answer into original equation. And then you can see what happens. So I have ln of x. So let's see what happens when you press in ln of 1. So when you have ln of 1, it's equal to 0. That's fine. What happens when you do ln of negative 5? It's error. It can't be so. So this is telling you, so ln of negative 5 is an error. That means the inside of the ln or log must be positive. So inside of log or ln must be positive. So we throw that answer out. So we had two possible solutions, but the only one that actually works is when x is equal to 1. All right, so let's try this again for example number 2. So we're going to use our rules of properties, and I have subtraction. Hopefully you remember what the subtraction means. Do you guys remember? That's right, it's going to be division. So I have ln, I have division, and I have this ln equal to 4. So up on top, I have this x squared minus 4. And down at the bottom, I'm going to have x plus 2. So I'm going to rewrite this. So I have ln, and I have my ln of 4. So the difference of squares, I have x plus 2 and x minus 2. Since x squared minus 4, that's how it factors. And down at the bottom, I have an x plus 2. Well, since I have an x plus 2 in the numerator and the denominator, it actually cancels out. So I'm left with the ln. And since an x plus 2 canceled, I'm just left with an x minus 2. So of course, if I e both sides, the e and the ln cancel out. So you're left with an x minus 2 is equal to 4. So I'm going to add 2 to both sides. So I can have that x is equal to 6. And I checked that in my original answer, and it works out. So check solution in original equation. And it works out. So x is equal to 6. For number 3, we have to take into account our power rule. So our power rule says we take that leading coefficient and we're bringing it up as the exponent. So I have my ln of x is equal to my ln of 16, and that exponent is 3/2, minus my ln of 2, and that exponent is going to be 3. Now, because I have subtraction, that subtraction is going to lead into division. So I'm going to have my ln, and so up on top, I'm going to have 16 to the 3/2. And down at the bottom, I have 2 to the 3rd power. So I'm going to go ahead and try to simplify this a little bit. So on my calculator, let's see how this is going to work out. So I have a fraction, and I have 16 to the power of another fraction, so that's 3/2. And then I have 2 to the power of 3. So 16 to the 3/2 divided by 2 to the 3rd power, and I end up getting 8. So that inside gets simplified to 8. So I'm going to go ahead and write that. Well, this makes this problem a lot more manageable, because once I e both sides so that they can cancel, I'm left with x is equal to 8. And I checked that in my original solution, and it works out. Okay, Now, switching gears a little bit, we're going to go into our word problems. It says if the number of compounding periods per fiscal year is finite, then the amount in an account is given by this equation, where P is the initial principal, R is the interest rate, N is the number of times compounded per year, and T is the time in years that the money is invested. And then we also have compounded continuously. So when it has that compounded continuously, this is our equation. When it's just compound interest, this is going to be our equation. So that one word can make the world of difference, continuously. Okay? Remember, E is continuous. So that's how you know that you're going to be using that formula. So the first example, it says, suppose $1,000 is invested at 5%. Find the balance after 8 years under the following options. So before I even figure that out, let's try to give some values to our numbers that we have. So we have our 5%. So that's going to be our rate, 5%. But we always want to write it as a decimal. So it's going to be a 0.05 as our rate. The next thing that we have is years. So that's going to be our time. So time is going to be equal to 8. And we also have that $1,000 is invested. So that's going to be my principal amount. So my principal amount is going to be $1,000. Okay. So now for part A, I can reevaluate everything. So I'm just going to write these values over to the side. So I have that my R is equal to a 0.05. I also have that my T is equal to 8. And I have that my P is equal to a 1,000. Okay. Now it specifically says compounded annually. Okay. So if it's compounded oops, didn't mean to do that. If it's compounded annually, then it's going to be that first equation with that compound interest. So annually means it happens once a year. So my N is equal to 1 since it's annually. So the equation that I'm going to be using, I have A of T is equal to my P, 1 plus R over N to my N times T. So I have my principal amount that I'm plugging in. So that's going to be 1,000. I have 1 plus my R value that I'm plugging in is a 0.05. The N value that I'm plugging in is 1. And that T value that I'm plugging in is 8. So I'm going to plug all of that into my calculator here. So I'm going to have 1,000 parentheses 1 plus my, well, I guess 1 plus 0.05 divided by 1 is just 1.05 into the power of my 1 times 8. Okay. So I'm going to get my answer as 1477.46. And the reason why it's 0.46 is because your money, whenever I'm talking about money, you always round to 2 decimal places. You can get 46 cents back from the bank, but you're not going to get 0.4555444 cents from the bank. So since it's always money, you round to the 2 decimal places. So I'm going to have my final answer as 1477.46. And so that gives me my final answer for number 1. Okay. For part B, it's slightly different. It's still compounded monthly. So it's still going to be that same green equation, except now because it's monthly, well, how many months in a year? 12. So 12 represents my M for my monthly. So I still have my same equation, A of T is equal to my principal, 1 plus r over n, and the n times t. So I have my principal amount, which is my 1,000, times 1 plus my r value is still the same, that's still a 0.05. My n value here is 12. So I'm going to have n, which is 12, times my t, and my t is 8. So again, I'm going to plug that into my calculator. So I'm going to have 1,000 okay, and then 1 plus, and here's my fraction. So make sure to write it as a fraction, 0.05, and that denominator is 12, to the power of 12 times 8. So I'm going to get 1490.59. Hopefully you guys remember it was going to be that 0.59 because it's many and I always round to the 2 decimal places. So this is going to be 1490.59 since it's compounded monthly. And that makes sense that if you have the same principal and your same rate and the same time, that it would be different because this is compounded monthly, so that's more times that it's going to have more interest on it. Okay, and now for part C, it says compounded continuously. So for continuously, we're going to use a different equation. Remember, continuously, that's with that E. So I'm going to rewrite it. My equation is my principal amount times E. Remember, E is just a number 2.71 something, kind of like pi, and the R times T power. And the R and the T has not changed, or even my principal amount. So I already have all of my information. My P value was that 1,000. E is a number just like pi. My R is that 0.05, and that T value is 8. So I'm going to plug that into my equation and see what I get. So I'm going to have my 1,000 times E. Oops. Let's go back. So there we go. E to the 0.05 times my 8. So I'm going to have 1491.8, and it should be 82 or 83. Well, since that 4 is less than 5, I'm going to leave it alone. So it'd be a 0.82. So I'm going to have my final answer as 1491.82. So it looks, out of all of those different options of A, B, or C, I'm definitely going to have C compounded continuously make me more money. Okay. And that is the end of 11.5. If you guys have any questions, please email me or contact the Math Success Center. Thank you.